Good afternoon, ladies and gentlemen. This is Mr. Picard, your well-rounded math teacher, and we're going to be going over 6-1 investigations with properties of exponents. So we'll jump right into it. We're going to expand this out so you can kind of see how it works. We're going to multiply 2 to the third times 2 to the fourth, but expanding it, it kind of means this. Well, 2 to the third is 2 times 2 times 2. 3 of them. And 2 to the fourth, 2, 3, 4. There's 4 2's. So how many 2's are we multiplying all together? Well, you can drop parentheses because it's all multiplication. And if you count them up, 1, 2, 3, 4, 5, 6, 7, that's 2 to the 7th power. Okay? We'll jump down and do this one down here because I don't want to expand to x to the 12th, but it's the same thing. 10 squared is 10 times 10 times 10 to the 5th. There's 3, 4, 5 10s that we're multiplying here. So how many 10s are we multiplying all together? 1, 2, 3, 4, 5, 6, 7. So that's 10 to the 7th. Now if you look at that, that's a 2 and a 5. How'd we get 7? That's a 3 and a 4. How'd we get 7? You're adding the exponents. So if you're multiplying like bases, which we are right here, x to the 5th times x to the 12th, you really add exponents. So that's x to the 17th. Okay? So what does that look like? These have the same base, a. And when we multiply, we add these exponents. So that's going to be to the m plus n power. So you can write a sentence explaining this. When multiplying like bases, it means they just have the same base, same number, same variable, whatever. You add exponents. Okay. Let's go on to number 3 here. So now we're dividing, and they have the same base. And it kind of looks like this. This would be 4 to the 5th, so I'd have 4, or actually 5 4s on top of my fraction bar, and 2 down here. So first of all, what is 4 over 4 equal to? Well, 4 goes into 4 once, that cancels out to 1, and the same thing up here. So 1 divided by 1 is 1. So they just cancel out to 1. So when I'm looking at this, these 4's cancel out to 1. Not negative 1, but just 1. These also cancel out to 1 over 1. And then you have the 3 4's left up here, so that becomes 4 to the 3rd power over 1, or just 4 to the 3rd. So you can see what we're going to be doing here with the 5 and the 2. Well, the difference between 5 and 2 is 3, and that's where you get 4 to the 3rd. So you're subtracting exponents. So if I do this one right here, I got 8 x's. 1, 2, 3, 4, 5, 6, 7, 8 over 6 x's. And once again, if you look at x over x, well, that will just cancel out to 1 over 1, or that's just equal to 1. So these reduce or cancel out to 1's. And I'm left with x squared over 1, or just x squared. And you can see that 8 minus 6 is 2. So you're subtracting the exponents. So here we got 12, and here we got 5. So really, and we have the same base. That's 0.0, actually, it's 0.95, and that would be to the 7th power over 1. And just dividing by 1, it's just going to give you 0.95 to the 7th. I put it in parentheses because the whole thing is to the 7th power. So how does this work? A little rule of thumb is you subtract these exponents when we're dividing. So this becomes a because they have the same base, a, to the m minus n power. So if I'm going to write next sentence explaining this, when dividing like bases, we subtract exponents. Okay. So this one, it's a little bit different because the higher exponent is in the denominator. So what does that look like? Well, I got 3 2's up here and I got 4 2's down here, and it's all multiplication. So these two would cancel out to 1, 1, 1. So what do I have left? Well, everything cancels out on top. That's just equal to 1 up there and 2 in the bottom. And that's 2 to the first. Well, it makes sense because you have more 2's down in the denominator. So that's 1 over 2 to the first. If you do the 4's here, 1, 2, 3, 4, 5 of them over 7 of them, 1, 2, 3, 4, 5, 6, 7, and then just cancel out corresponding 4's, I'd have 2 in the bottom. So on top you just have 1. They all cancel out, and it's just 1 left over 4 squared. Okay? Down here, well, I have 8 down here and I have 3 up here. So I'm just going to say I have 1 over x to the 5th. Because 3 of them would cancel out, you'd have 5 left over on the bottom. Now, if we use that rule that we did up here where it's m minus h, this is what you would get. You'd get 2 to the 3 minus 4, because you always subtract by the denominator, okay? When you're using that rule for dividing like bases, what you do with exponents. And this is going to give me 2 to the negative 1 power. Now, but the same thing over here, I got 1 over 2 to the first. And these equal the same thing. Here, I would get 4 to the 5 minus 7 power if you do it using that subtraction rule when you're dividing exponents. That would give me 4 to the negative 2 power, but that also gave us 1 over 4 squared. Okay? And they're the same thing. It's kind of weird, but they are. Here, I would get x to the 3 minus 8 power over 1. Actually, we'll just leave it as x over 3 minus 8. And that's going to give us x to the negative 5th power, which when we did it over here, we got 1 over x to the 5th. So if you look at all three of these, we have a negative exponent, but when we got the positive exponent, it's on the bottom in the denominator. So what does that mean? Okay, what that means is this. Usually when you simplify these expressions with these monomials, these exponents, you don't want a negative exponent. So to make it positive, it looks like you just flip it down to the denominator, flip it over the fraction bar. So if I had something like, I don't know, c to the negative third, well, I don't want to the negative third. So what I need to do when you're working with these negative exponents is make a fraction, flip it around the fraction bar. So this would become 1 over c to the positive third. Vice versa, if I had, I don't know, 1 over t to the negative second. Now, that's in the denominator already, so I would need to flip it up to the numerator to make that a positive 2, or just t squared. Okay? So what's the rule of thumb here? Well, if I have a to the negative n, put that over 1, we're going to flip that down. A to the negative n is the same thing as 1 over a to the positive n. You just got to flip it around the fraction bar and then change your exponent to a positive exponent. Explain your results. Well, to make negative exponent positive you flip it around the fraction bar, over it or under it, whatever it is. Okay. So let's get into this. Write an expression in expanded form. Okay, now this one's a little bit different. Now you have parentheses with an exponent outside of them, like that 4. When you already have a base and an exponent inside the parentheses. So what do you do with that? Well, trying to explain this a little bit. Well, I have 2 to the third, but 4 of them. So I have 2 to the third times 2 to the third times 2 to the third times 2 to the third, 4 of them. Well, when we're multiplying like bases, and they're all 2's, they have to be the same base, you add exponents. So this becomes 2 to the 3 plus 3 plus 3 plus 3. That's 12. 2 to the 12. Same thing here, x to the 4th, but I'm squaring that, so I have 2 of those x to the 4ths. Add the exponents, that becomes x to the 8th. Well, how do you go from 4 and 2 to 8? How do you go from 3 and 4 to 12? Well, when you're raising a power to another power, one exponent raised by another exponent, you multiply exponents. So here, m raised to the n power, you multiply it. That's mn. So when it's a power raised to another power, or an exponent is raised to another exponent, or I should say by another exponent, you multiply the exponents. Okay? So just do another example here. Let's go w squared to the, 7th power. Well, power to a power, an exponent raised by another exponent. You multiply it. 2 times 7 is 14, so this is w to the 14th power. Okay, so now we got a couple things in there raised by powers. So how do we do that? Well, if I'm going to expand this, this is 2 times x times itself 4 times. So times 2 times x times 2 times x times 2 times x. And if you multiply that all across, we'll multiply the common ones, 2 times 2 times 2 times 2. That's basically 2 to the 4th power. You're multiplying 4 of them. And then there's a 1, 2, 3, 4 x's to the 1st power. That becomes x to the 4th. So what you're doing here is this is 2 to the 1st, and this is x to the 1st. You kind of distribute that 4 to the parentheses here to both those exponents. So you're just multiplying 4 times 1 and 4 times 1. Now, I'm not going to multiply 3 times 3 here because this 3 is not an exponent. So, but it is 3 to the 1st power here. So when we're doing this, you kind of distribute it through the quantity. That becomes 3 to the 1 times 3. I'll put multiply here because there's an exponent raised to another exponent. That's going to be to the 3rd. And then this 2 times 3 here is 6, so that's x to the 6th. 3 to the 3rd is actually 27, so you could say 27x to the 6th if you wanted to, but this is kind of what we're doing for right now. So how do we do this now? Well, this is a to the 1st, b to the 1st. You distribute the exponent. Through the quantity. Quantity just means parentheses. Okay, so this would become a to the n, b to the n. And that's it. So you could just say distribute the exponent through the parentheses, we'll say, instead of quantity. Through the parentheses. There we go. So let me do another one quick here. Let's go, I don't know, 2x to the fourth y to the third power. Okay, I'm not going to, I know this is a 1 here, so I'm going to multiply 3 times 1 and 3 times 4, but I'm not going to multiply 3 times 2. I multiply it by the exponent there. So that becomes 2 to the third, 3 times 1, x to the 12th, and y to the third.
That would be what you did.
Yep. 2 to the third, that's 2 times 2 times 2, so that's 8, x to the 12th, y to the third. So finishing this up, these true or false questions, these are good questions, and I'll let you guys finish up the 5 through 10. True or false? Is 3 to the 5th times 4 to the 2nd equal to 12 to the 7th? 3 times 4 is 12, but these are not like bases, so I can't add the exponents. You'd have to figure out what 3 to the 5th is and 4 to the 2nd. Well, that's 16, and then multiply them that way. But this is false. If it was like 3 to the 5th times 3 to the 2nd, yes, that would be 3 to the 7th because they are the same base, okay? Let's look at this one. Is 100 times 2 to the 2nd equal to 2 to the 200th? This is also false, and here's why. I'm not going to multiply 100 times 2. You're going to do exponents first. This should be 100 times 2 squared is 4. This is 400. So, yeah, that would be wrong. Okay. 4 to the x over 4, well, that's actually 4 to the first. Now, when they have the same base and they both are 4, you subtract the exponents when you're dividing. So this would actually be 4 to the x minus 1 power. Not this. This is also false. Okay? Or if you had something like 4 to the 7th over 4 to the 3rd, 7 dividing, these are the same base, 7 minus 3 is 4, so this would be 4 to the 4th over 1, or just 4 to the 4th. Okay, where's the other one? Okay, so this is a little bit different because you have 4x to the 6th times 2x to the 6th. Now, when you multiply these terms, you do multiply 4 times 8. Or 4 times 2 and get 8. And then the x's, they have the same base. X to the 6 times x to the 6, you add exponents, and when you add the 6 and the 6, you do get 12. So this one is true. Good. And then here, I'll let you work on these. And we'll see you next time. Thank you.